Sometimes you just have to use a relay for something. And the problem with relays is the coils can draw a lot of current. Small ones do about a watt, and large relays can be 10 watts. And that's just drawing continuously. And there's a way around that. Relays typically have a pull-in and drop-out voltage. And so this is a 12-volt relay. This is a 30 amp. I didn't have anything bigger here, but it's just a generality here. This one actually pulls in at about 6.5 volts, and it'll drop out at around 3.5 volts. And so we can set this thing up for 5 volts, and that's a good hold-in. If you try getting too close to this 3.5 volts, if you have any mechanical vibration, a little tap of the relay and the armature will dislodge. This is due to the fact that there's an air gap, but once you close that, the magnetic strength increases dramatically. And so what we do on this little buck converter is at the pot. Typically you have your sensing from the voltage of the output with this variable resistor. And then there's a lower resistor, it's connected to the minus side, and this reference voltage goes to the regulator, which is typically about 1.25 volts. These can vary all over the place, but 1.25 volts is a standard band gap voltage. So what we do is put a capacitor across this, and that makes this resistance look very low. And so it'll drive the voltage high for a period of time until this charges up. So let's just turn this right on. So you can see by the time the meter could read, it's at 5 volts. And if we drop down, so this drops out about 2 volts. Let's go up again. 5. So, yeah. Huh, 3.5, 2.5 volts dropout, which is, must have been, don't get old, your eyes get bad. And speaking of getting old, anyone tells you electronics is a cheap hobby, it's not. I had this nice little buck converter here with a digital display on it. I really like this. And I had an errant wire get loose and blew this up. So yeah, this little video cost me. But you can do this, and that can drop your power requirements really enormously if you can go from having a 12-volt relay to having it just being powered by 5 volts. So this is only about 1,000 UF. 470 would probably work. I prefer to stay higher. As you can see, you can still relatively adjust it. There's a little bit of a time delay. But you can operate relays at much lower current, and you don't have the heat. This is something very standard. Like if you go to kilovac relays, they have a module that comes with many of them. And that's because that's a big 100 amp relay, and they know it's going to take a lot of heat, and you're reducing all that heat. And it's far more efficient. You're drawing less current because you're using a buck converter. You could have done this with a dropping resistor to the relay with a big capacitor across it, but you're still putting current through the resistor, and that's heating up. This is far more efficient, It's precise, and that's it.